Okay, let's continue our discussion from the last video. In last video, we have seen how many flops your CPU can perform, and we have calculated that. We also calculated in gigaflops and teraflops. If number is huge, let's say in 10 to the power 9, we calculate in gigaflops. If it is even bigger, 10 to the power 12, or in order of 10 to the power 12, we will calculate in teraflops, right? And we have seen that code in last video, right? Now, taking forward that discussion, and I'm talking about specific CPU metrics or statistics today. So this is the task manager of my machine, and you can see different numbers here. We'll go through each number and we'll see its meaning as well as how it's impacting each other, right? Now, one important concept we want to see here is clock frequency or CPU clock frequency. That means how many number of operations it can start in a second. That's clock frequency. So it's indirectly related with the um, flops as well, right? So let's say this is to the 2.10 gigahertz. That means it can start around 2 billion instructions in 1 second, right? And just because it can start those many instructions in 1 second or execute that many instructions in 1 second, that doesn't mean that it will complete those instructions. Some instructions take more than one cycle. So even though it's max uh, frequency, you will not be able to complete all the operations in one cycle. Some operation takes more than one cycle as well, right? So flop and this clock frequency are little related, but they are different terms here, right? Now you can see here two things: base speed as well as speed. That means it is turbocharged. That means it takes extra power. So you can say at least we will get this much clock frequency, and at most we will get this. And this is the real time number. So it's keep on fluctuating, but at most you will get this number, right? Another thing is socket. That means we have only one socket or one CPU chip in this machine. That's why sockets is mentioned as one. Now it has 20 cores. Now earlier CPUs, there were only one core in one CPU. That means it was capable of handling, you can say multi-threading was always been there, but there was context switching, right? So one thread will execute at one time and it will save its data and register. Then another thread will come in and then it will execute. It will give a illusion or very good illusion of having that it is running something in parallelly, but it was never been parallel with one core. It was always been switching of the threads, right? But here we have 20 cores. That means we have 20 different CPUs or CPU cores which can run multiple instructions in one go, right? So a single application actually run multiple threads on multiple cores, or there can be multiple applications which can run their threads on multiple cores, right? So we have such 20 physical cores. Now initially problem was you see this base speed or clock frequency. More clock frequency you have, more power consumption it will have, and more power it dissipates, or probably more heat it will dissipate, right? So it will be not sustainable physically to increase or keep on increasing the speed. That's why manufacturers actually come up with the concept of having multiple cores on a single CPU chip, and you can run these kind of 20 operations in this machine simultaneously, right? Now there is another important concept which is hyperthreading, right? Some codes are capable of running more than one thread at once. Two, I think, maximum, right? So Intel or AMD, some of these manufacturers actually come up with the concept of hyperthreading, and some CPU cores are capable of running more than one thread simultaneously, right? And again, this is important. Not all CPU cores are capable of running hyperthreading. Earlier, I used to think it's a software limitation that CPU core is capable of running multiple threads, but some softwares or some software writers have decided not to actually have hyperthreading. But I was wrong for researching this particular video. I came across this concept that only some CPU cores are capable of running hyperthreading, others are not. So here you can clearly see 8 CPU cores out of 20 are capable of running hyperthreading, others are not, right? And that's why you see this 28 as a number here, right? So because 8 cores actually able to perform two different operations. Virtualization, yes, virtualization is enabled. That means you can actually use Hyper-V or any other virtualization technique, and you can create multiple VMs in this particular OS. So that's virtualization. And this is L1, L2, and L3 cache, right? So fastest cache. So CPU has its own cache, right, where it can immediately execute the data. So fastest one is L1, fast lesser than that is L2, and then get another lesser is L3. Now, by you can see we have different memories here, right? 1.8 MB, 28 MB, and 33 MB. So shorter the memory, faster the speed, because your CPU can easily find out or search the data within the cache, right? So L1 is the smallest cache, that's why it's the fastest one. Then L2 is still very near to GPU, sorry, CPU, but it's like little farther than L1, and yet another L3 is even farther than L2. So you can see as their sizes increase, their speed gets decreasing, right? Another statistic here is utilization. It's only 8% we have utilized here, and this is turbo speed, which doesn't remain constant. This base speed remains constant. We already spoke about it, and then there are other numbers here, which is not significant for, or their discussion is not significant for our CPU versus GPU discussion here. But you can see enormous numbers of threads are actually being run on this particular machine. So it runs more than 2500 threads and several handles and so many processes as well, right? So that's all, guys. That is what I wanted to discuss today. We'll further take our discussion on CPU versus GPU, and probably next video will specifically discuss about GPU if I don't get anything meaningful to discuss about CPU.